optimization word problems. We're going to break this up into a couple different videos there. We got a couple easier examples in this video, and we'll do a couple more involved problems in the next video. There's going to be a class, if you take some business stuff in college, your whole goal is to maximize profits and minimize costs right there. And there's just going to be a huge chunk of things where you're just going to be taking derivatives and setting things equal to zero. Because if you take a function where that derivative is equal to zero, right, and that derivative changes from plus to minus or minus to plus, you're going to have your maximum and your minimum values right there. So, a lot of this just centers around where that derivative is equal to zero on all these word problems. So we're going to apply some of our derivative knowledge in this section here. And we got a lot of support, a lot of videos here for you to kind of help us out. Most of these problems involve two equations, a primary equation and a secondary equation. The primary equation is what you're trying to maximize or minimize. Like if you're trying to maximize a profit, whatever your profit equation is, that's your primary equation, right? If you're trying to minimize a cost, that's your primary equation. And then that's the equation that we're actually going to take the derivative of and set that equal to zero. The secondary equation, another name for that, I usually call that the givens of the problem. They'll tell us that something must be true. So that's the secondary equation. You never take the derivative of that. That's the one you're going to use to help you with the variables into that primary equation right there. So a lot of times we'll just want to get one variable for that primary equation, take a derivative, and figure out where that's equal to zero. Now, in these word problems, we're applying these things, so we don't concern ourselves where the derivative is undefined in this section. We want to know where just the derivative is equal to zero. So if you have a fraction for the derivative, we're just going to concern ourselves where the top of that fraction is equal to zero. So let's go right to it. Let's do a couple examples here. Here's a pretty basic problem here, and then we'll do one word problem. That'll be the end of our video here. We're going to find two positive numbers that satisfy these requirements. The product of those two numbers is 192. And the sum of the first number plus 3 times the second number is a minimum. So when they tell us the product is 192, that's the given. So a lot of times I'll just write down, hey, my givens of the problem, the product of those two numbers. So if I call one number X, the other number Y, and I multiply them together, that's the given, right? The X times Y, that product is equal to 192. Not ever taking the derivative of that, all right? That's where we're just going to use that to help us with the variables right there. So I'm just going to leave that one alone for a second. Here's my primary equation here. Now, you don't necessarily have to label this as secondary primary, but it helps to write them both down. I usually write down maximize or minimize. So it says a minimum, which means we want to minimize. And then you got to call it something. Call it A, call it S, whatever. It says we're going to minimize the sum. We want the sum to be a minimum. So I'm going to call that S. And it says the first number plus 3 times the second number. So I'm going to go X plus 3Y. That's one of the numbers plus 3 times the other number. This is what we want to minimize. This is my primary equation. So eventually I'm going to take the derivative of that, set that equal to 0, and that's going to give us that answer right there. Now, it doesn't matter whether it says maximize or minimize, you're going to be taking the derivative of this and set it equal to 0. Now, before you do that, you want to get this in terms of one variable. That's what you use this secondary equation to help you do. Now, some of the harder problems, it will make a difference which variable that you solve for. Basically, you're going to look here and which one looks easier to solve for. Like this one, it doesn't matter, all right? So I'm telling you, it doesn't matter which one you solve for and plug into here, but there's going to be problems that are kind of pretty involved and pretty challenging where you're going to look at this equation, you'll be like, hey, there's no way I can solve that thing for the H, so I got to solve that for the R, and then that kind of determines which one you solve for and plug in right there. So this particular one, I'm just going to solve this for Y. And then I'm going to take that 192 over X, and I'm going to substitute that in place for the Y. And so I'm going to get this primary equation in terms of one variable. And so if I plug in that 3 times 192 over X, I can just make that 576 over X. And then once you have that in terms of one variable, now you're simply going to take the derivative and then set this thing equal to 0. So remember that this part here is really 576 x to the negative 1. So when we take its derivative, the derivative of x is 1, and then you're going to multiply by the power, decrease the power by 1. So that's going to be like negative 576 x to the negative 2. And then I'm going to get rid of those negative exponents always, like we always do, make that over x squared. Now, here's what I suggest you do, because sometimes if you don't do this, you're going to lose solutions there. Once you have a derivative and you have fractions broken up like that, I strongly suggest that you get one single fraction, because then we'll always get all the answers that we possibly need right here. So once I get my derivative, I'm going to just do a common denominator. So it's like I'm going to put an x squared right there, put an x squared right there. Get yourself one single fraction for that derivative. All right, so there's our s prime. And then remember, in this section, we don't care where the derivative is undefined, because these are all applicational word problems there. So you only concern yourselves where the derivative is equal to 0. So a fraction is equal to 0, where the top is equal to 0. And so when you square root both sides, you're just going to get x is equal to 24. Now, I know you're used to doing like a plus or minus 24, but the directions clearly stated we want to find two positive numbers. That's why I'm not worrying about the plus or minus right there. Now, what we need to do is pay attention always to the directions, like for college and for the AP test. Sometimes they'll ask us for the two numbers, and that's what this particular problem is asking us for. So that means I'm going to take the 24, that's one of the numbers, but I could go back and plug that into that equation I saw for y, and I can get my y is 192 over the 24, and then that gives me the other number is equal to 8. And so that's what this particular problem asks for, is what are the two numbers? All right, so when I do that sum, that's going to be the minimum sum, and the product of those two numbers is 192 right there. If you choose any two numbers that multiply to get 192, the sum of that x plus 3y won't be the minimum. That's the minimum answer right there. Sometimes on an AP test or a college class, they might say, what is the minimum sum? If they ever ask what is the minimum sum, that just means you take those two numbers and you actually plug it into that primary equation. And so you'll go 24 plus the 3 times the 8 there, that's just going to be 24 plus 24, and that's going to be 48 for that minimum sum. All right, so that's just a pretty basic setup, and get us used to that approach there. Now let's do one word problem, and then we'll be done with this video here. All right, this is a very important day in your young mathematical calculus careers, because this right here, we're going to introduce you to the famous cow problem. Every single calculus book that I've ever seen, going back to when I tutored in college, has this famous cow problem in it, where we're going to put up this fence and we're going to minimize the amount of fencing. We're going to maximize the green pastures for these cows to graze. Okay, so what we got a little sidebar here. I know some of you had Mr. Collier. Some of you might know who Mr. Collier is, even if you don't. I just want to mention, like, he strives, he kind of has a secret aspiration to be a farmer one day. He's obsessed with cows. Like, sure, he likes soccer, he likes baseball. You might know he's like a huge Cardinals fan. And he's actually, Mr. Collier is like one of the smartest guys. Like, he is the smartest guy that I know right there. But one little secret about him that you may not know is that he is weirdly obsessed with cows. Like, sometimes he'll be walking through the halls and he just like pretends he's a cow for a brief moment. He just goes, moo, and you're like, what the heck was that? And he does it with a straight face, so you don't even know it was him. So that's a bit odd to me. Sometimes when he goes on vacation, he'll visit a farm, and he likes that morning cereal. He goes to visit a farm just to milk the cows. And he likes his morning cereal with that fresh dairy, so you get that straight from the farm, milk the cows, get that fresh milk in there. And then sometimes he likes to brush the cows like they're dogs or something, like you brush your dog, he'll do that with a cow. And he actually trains cows in his spare time. He practices these tail exercises where, because I imagine if you're a cow, you got those flies that you got to swat off of you all the time, right? So he actually does like tail yoga with these things. And so whatever exercises he does with these cows, it actually strengthens their tails so that they're easily able to swat away those flies. And that just improves their overall quality of life and happiness, So he's a pretty good guy just helping out these cows like that, But sometimes he like forces his kid to dress up as cow, like in cow costumes for Halloween, One year he let him be like Star Wars, because he's a fan of Star Wars too. But yeah, dressing up in those cow costumes every single year, man, yeah, you gotta let them be something else, let them be a princess, let them be, a football player or something like that, let them just, be what they want to be. But anyways, so given that he's weirdly obsessed with cows, we're gonna devote this problem to the smartest dude I know, Mr. Collier there. So we got farmer Mr. Collier plans to fence this rectangular pasture adjacent to a river. So he's got, he's got this farm area, right? He wants to put this fence around, but there's this river right there. So that's kind of helpful, because You don't need 4 sides of the fence. You only need 3 sides of the fence. Now you might be wondering, hey, how do the cows know not to go into the river right there? These places actually exist. I have seen a couple farms where there is fencing and there was a river, and I did my own little research right there. It turns out that cows, they technically, I think they know how to swim. If I'm remembering my research correctly, that I think they know how to swim, but they're not good at it. And so they know not to go into the water. So you can actually use the river as one side of the fence there, and your cow is not just going to escape and try to swim away there. So, but look at this artwork right there. You got the sweet blue color for the water. We got a mulberryish color fence. You know, you got the ombre green for the pasture right there. And that cow kind of looks like a deer a little bit. I don't know, kind of looks like a stick figure dog a little bit, but it's even got like an oinker's tail, you know, like a pig oinker's tail right there. So it's just a nice cow drawing right there. But anyways, here's our actual calculus problem, right? The pasture itself must contain 120,000 square meters in order to provide enough grass for the cows to graze, right? You want to keep those cows happy. You don't want to like compress them too much, right? And then what we want to figure out here is what dimensions of that fencing, of that mulberry fencing, will require the least amount if no fencing is needed along that river right there. So we're going to minimize the amount of fencing. So when we go to the hardware store, we're going to be able to buy less fencing in order to save up some money. That's a good thing, right? And so we don't know the dimensions of the fencing. So I'm going to call this X. I'm going to call these Y. Usually if it's a horizontal, I'll use X. If it's a vertical variable, I'll use the Y. And here's what we're given. So we are told that the pasture must contain that much square meters. That's an area. So that means if I multiply X times Y, we're given that that's 120,000 square meters right there. All right, that's our secondary equation. And then it says we want to minimize the amount of fencing. So the amount of fencing, that's a perimeter idea. So I want to minimize, I'm going to call it F for fencing. That's just the perimeter. So it's just going to be X plus 2Y. That is our primary equation. We don't have any fencing along the river. So it's just one of the X's and 2 Y's. So this is our primary equation. Pretty simple stuff. And we're going to take the derivative and set it equals 0. But before we do that, we have to get this in terms of one variable. And since we solved for Y in the other problem, and I told you it didn't matter, this time I'm going to solve for X on this problem. It does not matter. And I'm going to take that and I'm going to plug that in place for the X right there. And so I know I'm getting ready to take this derivative, so I'm going to move that up already. So we'll get 120,000 Y to the -1 plus 2Y. Now, once that primary equation is in terms of one variable, we can go ahead and take the derivative. So I'm going to multiply by that power, decrease the power by 1. Now, when that becomes Y to the -2, I'm automatically going to drop that down to the bottom, make that Y squared on the bottom. And then you're going to get the derivative of 2Y is just going to be a 2 right there. And then if I have the fractions broken up with the variables, I'm going to get myself a common denominator, one single fraction after I take that derivative. And so we're going to have this 2Y squared minus 120 grand on the top over that Y squared. And then we're just concerned, there's our derivative. You're only concerned where the top is equal to 0. We don't care where the derivative is undefined in this section. So if I set this equal to 0, we'll get Y squared is equal to 60 grand. And then we'll square root both sides, and we're going to get a 245. Negative 245 meters of fencing doesn't make any sense right there. So we get 245 meters right there. And it wants to know what's the dimensions of the fence, which means I got to take that 245, substitute that back in place for the Y. So we get 120,000 over the 245. Now I just kind of made these numbers up off the top of my head right there. So they don't, you know, we're going to just kind of round for this stuff. They're typically on the harder word problems, we'll get an exact answer for the first thing we find. And it's okay to get a decimal answer for the second thing that we find. If we can't get an exact, we can, but usually we'll get a decimal answer for that second thing that we find. It turns out that the X is going to be about 49.796 meters. And then, so that's what they ask for, is what's the dimensions of the fence. So I got my 2 dimensions. And then if, just in case, just if they ever did ask for what is the amount of fencing, you would take those X and Y's and you would plug those in. So you would go to 49.796 plus 2 times that 245. And then that means the amount of fencing that you know you need to buy. So is this 979.796 meters. All right, so that is the fencing that will give us our desired area, and it'll be the least amount of fencing that we can use right there. So when we go to the hardware store, we know exactly how much fencing that we're going to buy. In this section, if it tells you to maximize something or minimize something, I just want you to do the same thing for both of them, all right? In college, they'll probably have us do something called a second derivative test to verify it's a max or min. Right now, I'm just going to tell you with my experience with these problems, if they tell us to maximize or minimize something and you only get one answer, that is the maximum, that is the minimum. And we'll discuss at some point, you know, if we get a couple different answers, we'll discuss how to verify which one's the max, which one's the min, and make sure we get our proper answers on there. Okay, so just practice those, get those basics down, and then I'll make a separate video of how to do some more involved problems for that. Thank you.